Hi, my name's Adam Minnie, and I'm with Sage Innovations, and I'm here to talk today about VLANs. Periodically, I get questions about security as it relates to implementing voice over IP. This is particularly important when it comes to banks and other institutions that have compliancy requirements, FDIC, Sarbanes-Oxley, HIPAA, and other kind of security requirements. So the most basic way to do it is through the traditional method of VLANing. I've depicted a diagram here of two sites, Acme Site 1 and then the Acme remote site here. Each of these sites have a QoS LAN. This generally is vendor agnostic. This is standards-based technology, so we're talking, all the standard HP, Cisco's, Brocades of the world would all support this in a managed environment. So we have a managed switch here and we have a managed switch here, and basically what we're going to do is a VLAN is effectively a way to segment a physical environment. Actually, two VLANs can travel across the same cable, and that information cannot communicate with each other. So those two VLANs cannot talk, and we'll talk about what that means. So basically what I've done here is I've defined two VLANs, VLAN 1, which is our data VLAN, and VLAN 5, which is our voice VLAN. So what we're going to do is we're going to go and where the devices plug into the network, on the network switch we actually get to define what VLAN that's a member of. So VLAN 1 is data, we said, so we're just going to quickly run around and tag our switch ports for what they do. So VLAN 1 for our PCs, our servers here. We could put the phone system in VLAN 1, but we want the phones to talk to it, so we're going to put it in the phone VLAN, same with the gateway. Now the router is kind of tricky because it actually gets access to both VLANs, so we're just going to quickly go in here and we'll just give it access to both of those, and we'll talk a little bit about that. That's how that works. And so I'm going to go ahead and bring that to the front here so that it looks good. And so we have both VLANs, we have everything tagged down here. Now we need to go back and tag our voice environment. So we have VLAN 5 that can be spoken to for the phones here, and we said that the gateway would be, and the phone system would be. And so basically, in the simplest form, we'll work the remote site here, and then we'll create some more VLANs and we'll run around and tag everything, but you get the concept here. First we're going to do a traditional data path, and so we'll come in here and we're going to send a packet, an email request or a banking request would be best, from this user to a server. And so basically what would happen is a request from this PC would leave this PC, enter the LAN on VLAN 1, and since it's on VLAN 1, it can talk to anything with VLAN 1. So since it's able to talk to the banking application, it could do so. It can go ahead and return its path and communicate back. The server can communicate in this way with anything on its own VLAN. So it could communicate out, the PC itself could communicate out via the router and cross the WAN to have dialogue with the remote site. So those things all exist and can be done no problem. If a user, let's say, were to try to just clear off this traffic, if a user were to try to actually access, say, the phone system directly without permission to do so, that wouldn't happen. Also, if a user tried to cross over and talk from the PC to the phone, that wouldn't happen, because you can see here that they're actually in different VLANs, and so they actually wouldn't see each other. Any broadcast traffic that might go from phone to phone to phone would actually not even come to a port which isn't tagged for the VLAN that it's on. So there actually is a segmentation that exists there, and so there's no way for those two VLANs to communicate with each other. Now, let's say we needed a communication to happen. Let's use it as an example. I need to do a screen pop on a computer here. Well, what would happen is the packet would leave VLAN 5 and in turn go to the router and be routed back, and that traffic would then enter the appropriate VLAN, and I could then send a screen pop to that user. Now, what's important here is there's something called an access list that exists in this router here, and it's telling us that anything with a source of this phone system server is allowed to go ahead and talk to other devices on the network and cross VLANs, whereby we would restrict everything else. So any other external resources that might occur, also from VLAN to VLAN. So as an example, if you didn't want traffic to cross over to a production banking environment application or something, you'll be able to segment those as well. But now, as we work through this VLAN session, it's important to understand a few things. In most voice over IP deployments, the VLANs aren't flat like this. Typically what happens is the phone itself plugs into the actual LAN, and the PC plugs into the phone. And so the true depiction of what we're talking about here would look something more like this. The PC plugs into the phone plugs into the network, and what happens is both VLANs are assigned to each port. Now, you would think, well, that's crazy because now both devices have access to each. No, what really happens is the packet, as it leaves each of the devices, it's either tagged or untagged. And so if we were to define traffic that left, as an example, this workstation and went out, crossed the network, now it left VLAN 1, we'll talk about that, because remember the data VLAN is VLAN 1, and went to the banking application, and then in turn came back and returned to the PC, one would think since it passed through the phone, it actually has to go to the phone VLAN, and that's not true. What actually happens here is in the switch we define VLAN 1 as the untagged VLAN, so I'm going to say untagged traffic. And so at the front of the IP packet, when the IP packet itself leaves the PC, in this case, travels through the phone, which is the physical layer, there's no data exchange happening here, and comes into the switch is inspecting the packet and saying, aha, that's untagged, and so it's part of VLAN 1, and so it'll have access, just like it does today, to anything with VLAN 1, but not to anything with VLAN 5. So now what happens on the phones is the phones are tagged with VLAN 5, and so in this way their tags say VLAN 5 on them, and so when a packet leaves the phone, i.e. a voice call leaves the phone, it enters, and the inspection of the switch says, aha, you're in VLAN 5. It places that packet in VLAN 5 on the switch, and it would then at that point have access to anything with VLAN 5 for the purpose of communication. Now, again, it's tagged traffic in VLAN 5, and so it has no access to actually communicate with any devices on that VLAN. Add additional sites, same methodologies hold true. So I would want to tag both VLANs as they carry over here, and as we bring those in, we'll just tag the appropriate ports just like we were doing before, and in that way something on VLAN 5, as we're kind of laying out here, would be acceptable for those devices to talk across the WAN. So let's say, for instance, we wanted to place a phone call and it was local out of a remote site that would cross the network. In this way, maintaining VLAN 5, so maintaining separation from the data network, really, from the production environment, and I could send that call out something like this outside world, like a least cost routing type of situation where it would be cheaper to call from a different city. So anyway, a couple different ideas there with QoS. VLANing, and if there's anything that you need help with, any questions that you might have, hit me up. You can reach me at amenne, that's AMENNE at sage, VOIP advice.com, or you can give me a buzz at 314-852-5800, and I hope this little video helped. Have a great day.